Welcome friends. Today we discuss some questions from the heating effect of electric current. We take it as the two parts. First part we take problems or questions from Joule's law and electric power, and the next part we will do problems connected to arrangement of resistors in circuits. And we start with that problem given in table 1.3. In that problem, details of two electric heaters are given. How much will be the heat developed if they are made to work for 5 minutes each? The question is solved in the table 1.3, and after the table they have given some questions. Question like this: why does the heater having low resistance get heated more? In which way does the change in resistance influence the heat developed? Find out the current in the heaters A and B and compare the heat developed. And the last, how do the resistors bring about a change in the current in the circuit? The problem has already solved in the table. That working voltage 230 volt and resistance 1150 ohm for that first heater working in 5 minutes time. And H is calculated using Joule's law. H is equal to V square T by R, and answer is given there 13,800 joules. Second heater B, working voltage is the same 230 volt, resistance is 460 ohms, and working time is the same 5 minutes. Heat energy, the same formula they have used, V square T by R, that is 34,500 joule. For doing these type of problems, I will introduce you a pie diagram connecting variables P, V, I and R. It is very much useful to familiarize that table so that it is very easy for all these calculations connected to our Joule's law and power. Before coming to these answers of the question, I would like to link the same question to another question which is given there in the assess part of that last part of the chapter. Let us assess. There is a part. There is a question, the question number 4. There also a table is given. Table with some values of voltage and resistance, and some columns we have to fill. An example is given there. First row is filled and second row onwards you have to fill. And there are also some questions. That questions we will answer after analyzing the table. With these two tables and analysis, we can answer both the questions of that table 1.3 as well as that assessment part question number 4. Let us go through the table. Operating voltage 230 volt. Next column is resistance R 57.5 ohm. Current flowing I V by R 4 ampere, and heat generated per second, that is in 1 second. H is equal to VIT, where T becomes 1, so VI 920 joules. It is heat. And next column is power given by the device. P is equal to V into I, that is H by T. As T is 1, P and H will be the same, but unit will be different, 920 watt. Reason for the change in power, that we will see later. Now the rest we have filled the table in the same manner as given in that particular equations at the top. We have calculated for the next columns. Then you can see from the table. See here, I have split that table into two separate tables. You have to analyze these two tables. First table, I have rewritten the table like this. R, V, I, P, R resistance 57.5. From all that rows, 57.5 resistors I have selected and their respective columns I have posted here. 115 to 230 and this one 230, 4, 920 and 468, 3680. Next table, I have written voltage first, resistance, amperage and power. These are there in the table itself. Now, resistance 57.5, current I 4, that current I 4 ampere and power 920 watts. Here 150 resistance to 460. Here 230 volt, 230 ohms itself. So current is 1 and power is 230. Now let us see this only to get some idea about the device as well as the voltage. Now look at this table. Here R is same. If R is the same, we are telling about a particular device. So here it is applicable for a particular device. The device is the same. Resistance is the same means device is the same. Okay. Now for that particular device having resistance 57.5, if voltage is 115, current is 2 and 230 current is 4 and 460 current is 8. So we can correlate or connect V, I and P for same R. What is the relation? Let us see. When voltage is increasing, 115 here, becoming 230 here, becoming 460 here, current is becoming again 2 becomes 4 becomes 8. So we can write if voltage is increasing, I am just putting an arrow upward showing voltage increasing, current also increase. Current increases with the voltage. Now what about power? Power 230, 920, 3680. Power is also increasing. So with the voltage, current will increase and power will increase. Just opposite if you think of, if voltage is reduced 460, 230, 115, current will be reduced 8, 4, 2 and power will be again reduced. 3680 becomes 920 becomes 230. So just opposite. So if we are writing voltage decreasing, current is decreasing and power is decreasing. One and the same in two directions. One is ascending order, other is descending order. And they will keep some relation. If voltage is doubled, current is also doubled. But power won't be doubled. This situation we have seen in one of our earlier videos. But that voltage and current will give the power. So if voltage is doubled, what is doubled is not the power but current. This is from Ohm's law. Now comes next table. Here voltage is the same. So V, voltage. What does it mean? When voltage is same, what does it mean? Supply is the same supply. That is same supply. So in the circuit, we are not changing the voltage. So we are connecting devices in the same voltage. This is what we are doing in our household circuit. We are connecting different devices with different resistors or with different current or different power in the same 230 volt. In parallel connection we have already seen last class. Now let us see, here voltage is 230, which is the constant here, that is in the same circuit. Resistance here 57.5. Sure, it is of a particular device and its current is 4 and power is 920. Now this resistance for next device it is 115. If resistance made 115, that is it doubled. See current, it became 2, that is half. If it is double, it became half. And what about the power? Power is 460. So if I is made half, here power is also made half. Now 230, resistance again increased, current is again decreased, 1 became 1. So if it became 230 means 115 became 230, or 157.5 becomes 230, that is 4 times current will become 1 by 4th. If you think of these two, that resistance becoming twice, current is becoming half. Here resistance 4 times, current 1 by 4th. So resistance, current, we have to compare these two. Then what about power? If current is 4, power is 920, this is 460, and when current is 1, power is only 230. So we can compare like this. We can write R, I and power P. If R is increasing 57.5, 115, 230. So if R is increasing, what is happening to I? I 4, 2, 1. I is decreasing. What about power? Same rate. Power is decreasing. So this is the relation when same voltage, different resistances, that means different devices. So if it is a bigger wattage instrument or device, its resistance will be less, current will be more. Here power is 460, just reduced, power reduced, so current also reduced, resistance increased. And here is only 230, power is less, current will be very less, and resistance will be maximum 230 among these three. So this type of relationship we will get. Now we can come back to our questions. See that questions once again. Just below this table they have given the questions. In that first question, how does the voltage under which a device was affect functioning? How does the voltage affect functioning? Voltage and functioning means the way it is producing heat energy. If it is a heater, heat will be different. That heat energy will be different. How? If voltage is less, heat energy will be less or power will be less. If voltage is more, heat energy will be more or power will be more, and current will be more. The current case they are not asking how it will affect the working. Working means how efficient it is. Here 3680 is the wattage of this instrument because it is having voltage of 460. Naturally, current in between will be increasing. Now let us see the next question. I hope you got that point clear. That is the relation between voltage and power of a particular device. If voltage is increasing, power is increasing, but the device is of the same resistance, same device. So a device having the same resistance, connected voltage makes some difference in its output. Okay, that is important. Now next question, let us see. What change happens to power on increasing the resistance without changing the voltage? What change happens to power? Change in power, same voltage if resistance is increasing. Now this second table will give you the analysis. Voltage is the same, but resistance is increasing. That means sure it is of different devices, not the same device. One device is of 57.5, power is 920. This resistance is 115, its power is 460, and 230, power is 230. If resistance is greater, power will be less. Now, one more question is there. Third question. What change is brought about in construction of household heating device in order to increase their power? What change we have to do in the construction of a device in order to get increasing power or greater power? What to do? If you want greater power in the circuit, what type of device we have to design that designed in such a way that the resistance must be smaller. So we make thick heating element. If the heating element thickness is greater, we know resistance will be less, current will be more, we get power more. This is the same thing we have seen in the case of 100-watt bulb in our demonstration that day. If 100-watt bulb filament will be always thicker than 25-watt bulb, because 25-watt the resistance is greater, current is less. In case of 100-watt bulb, resistance is less, so current will be more. To make greater current, we have to increase the thickness. We have studied thickness of the wire. If it is more, resistance will be less. So what type of construction we have to do? We have to construct coil or heating element with less resistance if you expect a greater power. If you want again greater power, this resistance should be again less. Smaller the resistance, greater will be the power. With this information, let us go back to that first part that we have started, table 1-3 question. There they are asking about that two heaters. From comparison of these two heaters, they are asking about why does the heater having low resistance get heated more. I'm sure all these questions, though we didn't discuss anything there, we discussed all these points here, you can answer the questions there. So what are the questions we have to answer? Let us see. Why does the heater having low resistance get heated more? Having less resistance, we already studied. Smaller the resistance, current will be more, so power will be more, or heat energy will be more. So you have to intermediate current you have to explain. So when resistance is smaller, current is higher, so we can have greater energy. Now next question. In which way does the change in resistance influence the heat developed? Change in resistance. Yes, the change in resistance influence heat developed. Can't you answer? Try. What is happening here? If resistance is increasing, heat energy is decreasing. Because if resistance is increasing, current is decreasing. Now third, find out the current in the heaters A and B and compare the heat developed. So their voltage is 230 volt and its resistance is given for the first heater 1150 ohms. So what will be the current? Current is we know already, V by R. So 230 by 1150, that will give you 0.2 amperes. Now next heater, voltage is the same 230 volt, but resistance given 460. So we can calculate for the current 230 by 460. This is nothing but 0.5 ampere. So having 0.5 ampere current, we have seen the heat energy developed is 34,500 and 0.2 as current, the heat energy produced is 13,800. So that question is also answered. Find out the current in A and B. Now the last question. How do the resistors bring about a change in the current in the circuit? How resistor affect the current? We already seen if resistor increased, current decreased. So these type of questions you can expect for our examination with a particular value, sometimes generally, sometimes with a value or with a problem. If it is a problem, you work out the problem and do it. And if it is a general question, these general points you remember and you have to write that statement. If voltage is greater, current will be greater. If resistance is greater, current is smaller. And current and power in the same rate in change, and resistance and power in opposite range. This type of comparison you can do from the tables. I am sure you got the relation between these variables, current, power, voltage and resistance. So resistance is only a particular device. So you correlate always resistance device. Voltage with that supply. If voltage is same means same supply. Resistance different means different devices. Okay, we will discuss the next part, that is resistors in series and parallel and connected equations and problems. We will do in the next class.